So I'm going to talk about analytic idealism, but I want to introduce this by trying to convince you that we have made a major transition in the way we think about nature almost 2 centuries ago. People talk about quantum mechanics. That was almost a century later than what I'm trying to refer to here. And that transition after almost 2 centuries hasn't sunken in most of science, let alone most of our culture. And that transition was with James Maxwell that you see here to the left, who was the guy who proposed an interpretation of electromagnetic phenomena in terms of fields. In other words, we're not talking about things here. We are talking about fields that exist even in a vacuum, a complete vacuum. So James Maxwell proposed that the way to think about electromagnetic phenomena was in terms of fields, which are not things, because they exist in a vacuum. Radio waves go across a vacuum. That's why the Apollo 11 astronauts could transmit voice and video from the moon to us, crossing the vacuum of space. Fields are not things, they exist in vacuums. And the equations of electromagnetism were so explanatorily successful that the rest of physics took a hint. And it was with Feynman in the 40s, well, arguably since the late 20s, but there is controversy. So I'll stick to Feynman, who proposed that we should understand not only electromagnetism, but all of nature in terms of fields. And he began with quantum electrodynamics. And that evolved into what we call quantum field theory today, which is what you see illustrated here on the animation to the right, which is the notion that what reality is a set of fields. 17 was the latest count, but we try to reduce that to only 1 in the so-called grand unification theories. We haven't succeeded yet, but we are making progress, some progress. And what we call things are excitations of these fields. Like ripples on a lake. If the lake is the field, then things are ripples on the lake. In other words, there are no real things, because what is a ripple? A ripple is a behavior of the lake. There are no ripples, there is only the lake doing something. That's what we call a ripple. It's a doing of the lake. It's not a thing. And that's why you can't fish out the ripple from the lake. You can't take the ripple out of the lake and carry it home with you, because there is no ripple. There is nothing to the ripple but the lake. And similarly, under quantum field theory, everything that we call particles, elementary subatomic particles, are not things. They are doings of the fields. They are behaviors, patterns of excitation of the field. They are not things at all. But this still has not sunken in. We still think of reality in terms of things with some kind of autonomous ontic existence, while in fact there are no things, there are no particles. And if you disagree with what I've just said, you have to keep in mind that not only are you going against the most successful theory in the history of science as far as prediction power, you would have to abandon a great many things that we can only explain if we understand reality as fields. In other words, a special kind of vacuum and not as sets of things. For instance, you couldn't reconcile quantum theory with special relativity if you think in terms of things. You couldn't explain spontaneous quantum fluctuations in a vacuum. They would become magic. If you think of particles as things, then what we see experimentally is that particles come in and out of existence in a vacuum. That would be magical. Why is it not magical? Because there are no particles. There is only the field, which actually is the vacuum, and that field can become self-excited. We wouldn't be able to explain particle decay, which is a big thing in physics. I mean, I worked in the apparatus that eventually discovered the Higgs boson 10 years ago. I worked there 25 years ago. And people think we've measured the Higgs boson, that the Higgs boson has interacted with some kind of measurement surface. So you could make a direct measurement on the Higgs boson. That's not how it goes. Nobody can actually measure the Higgs boson directly because it vanishes very, very, very shortly after it comes into existence. It doesn't have enough time to interact with any measurement surface. So how do you know that the Higgs were there? Because the Higgs decays into other things. The Higgs can decay into 2 bottom quarks, can decay into 2 muons, as we've discovered, can decay into a W and a Z boson. In other words, the Higgs can become these other particles, but these other particles are not parts of the Higgs. There are no bottom quarks inside the Higgs. So how can a Higgs become 2 bottom quarks? It's magic. No, it's not, because there is no Higgs. There are no bottom quarks. There is a big ripple that decays into 2 smaller ripples. And we call the big ripple a Higgs boson, and we call the smaller ripples 2 muons or 2 bottom quarks or whatever you want. There are no particles. Particles are not things. Nature is not made of things. Nature is made of fields, which are a special kind of vacuum, a special kind of no-thingness. But this hasn't sunk in. And that's why we still think today in fairly old-fashioned terms. So that's what I wanted to review with you and introduce a different perspective on how we can interpret reality and why that's much more explanatorily powerful, empirically consistent, and even internally consistent. To start this journey, let's take a few steps back and, like Descartes did in his discourse on the method, and start from what is epistemically secure, things that we do know. For instance, all we have is perception. We infer that there is an abstract physical world behind perception. But the world of colors and melodies and flavors and scents that we perceive around us is a mental world. It's a world of perception. Now, obviously, there is something beyond perception that we all share, because if you were here where I am right now, you would describe my studio in a way very consistent with my own description of it. So clearly, we all inhabit some kind of ontological context that is beyond our individual minds. But to say that it's beyond our individual minds doesn't mean that it is necessarily not mental. Your thoughts are beyond my individual mind, but they are mental, even though they are not in my mind. Physics, what physics does is to describe the world of perception, which is a mental world. That's what physics describes. When we say there is a 1 kilometer distance from this town to the next town, that's a description of what appears on the screen of perception that helps us live. And that's what physics is busy with. Even things that cannot be perceived directly, say like a bottom quark. Nobody has ever seen a bottom quark. We see photons. But the bottom quark can be inferred based on a pattern of clickings on instrumentation. Now, those clickings produced by instrumentation are things we perceive. So even in that case, physics still is busy with building models to describe what appears on the screen of perception. The existence of a non-mental substrate is a theoretical inference, since we have no direct access to it, nor do we actually need it, because we can occupy a common world, and that world can still be mental, even though not part of our individual minds. Just like your thoughts are not part of my individual minds, they are objective from my perspective. If I were not here, your thoughts would go on happening. They don't depend on me to exist. In the same way, the world can be objectively there from our point of view, and be there regardless of whether we are here or not, and still be mental. Now, so having understood that what physics describes is the world of perception, we have to ask ourselves, is the world as it is, do we have reasons to believe that it is exactly as what appears on the screen of perception? In other words, is perception a transparent window into the world as it actually is? Do we see things as they actually are? And there is a categorical answer to this question, which is no, the world cannot be like what appears on the screen of perception. And there are at least 2 independent lines of reasoning to, I can say, prove this assertion with a very, very high degree of confidence. In other words, to prove it. One is entropy. And there is a very sophisticated mathematical argument about it, which I'm not going to get into. I originally made these slides for a physics conference, but I will give you the taste of it. And the taste of it is the following. We have our brain. Here is our brain. And our perceptual states correlate with the brain. What we call perception is a set of states that map here to the brain. And the world outside is constituted of states. For us to see the world as it is, there would have to be a correspondence between each state of the world outside to a state in the brain. And this correspondence would need to be such that our inner cognitive states mirror the states of the world. Cognition would have to mirror the world. That's what it means when we say perception is a transparent window into the world. The world as it is, its states are mirrored in our inner states. The problem is that there is no upper bound to the dispersion or the entropy of the external states of the world. Therefore, perception would guarantee no upper bound to the dispersion of our inner states. To put it in other words, there would be no guaranteed upper bound to our internal entropy, and that upper bound needs to be there, because if entropy crosses a certain threshold, that would be incompatible with our ability to maintain our structural and dynamical integrity. To make it as simple as possible, I like to say that if we were to mirror the world as it is, we would dissolve into hot soup. And this could even be literally so, because what is soup? Soup is when you raise the temperature of a set of compounds so much that they dissolve and mix together. In other words, when they have high entropy. And since the entropy of the world cannot be a priori guaranteed to have an upper bound, if we mirrored the world in our cognition, we would run the risk of melting into hot soup by merely looking at the world. And now nobody melted into hot soup yet, which is good grounds for us to say, and this is mathematically very well substantiated, that our cognitive states do not mirror the world. They are encoded inferential representations of the world. In other words, what we see is not the world as it is. It's a representation thereof, highly encoded in order to bound our inner entropy. Another line of reasoning is evolution. We would never have evolved to see the world as it actually is, because this is counter to fitness. It's counter to survival. And this is put forward by Donald Hoffman and his team at the University of California. And the argument here can be illustrated with a metaphor. Suppose that you could see the computer files on your computer exactly as they actually are. What is a computer file? A computer file is a set of millions upon millions of open or closed microscopic switches within a silicon chip. If you could see every file in your computer as they actually are, you wouldn't be able to use your computer. That's not conducive to function. You wouldn't be able to do anything. You wouldn't even know what file is what or how to edit a file. Your computer would become entirely useless. Now, bringing that back to evolution, if we could see the world as it is, we wouldn't be able to react promptly to environmental challenges, and we would be driven swiftly to extinction. The fact that we are not extinct can be construed as proof that we do not see the world as it actually is. So what is the world then? What is this world that we see? It is a dashboard of dials. This dashboard is important. We should take it seriously. Pilots can fly by instruments alone. They don't need a transparent windshield to see the world as it actually is. They only need the dials, because the dials convey accurate and actionable information about the world. And the dials on the dashboard also limit the entropy. They have limited entropy. The scales of each dial only go from 2 points. They don't go beyond, and there are just that many dials. That's why airplane flight manuals can be written, capturing every combination of measurements shown in the dials that is relevant. The entropy is limited. But the fact that the dashboard conveys accurate and actionable information about the world doesn't mean that it is the world. neither does it mean that the world is like the dashboard, because it is not. The dashboard of an airplane is not the sky outside. And it doesn't look like the sky outside. It just conveys accurate and actionable information about the sky outside. Now, I submit to you that what we call colloquially the physical world is a dashboard. That's what physicality is. It's a set of representations that ensure that our inner entropy is limited and ensure that we can react satisfactorily and quickly enough to environmental challenges in order to survive and reproduce. When we say that the world as it is physical, we are making the same mistake a pilot would make if he were to say, the sky outside is the dashboard. My dashboard is the sky outside. No, it's not. It doesn't mean that the dashboard is an illusion. It's not an illusion. It doesn't mean that the dashboard should be thrown out. No, you will crash the plane in both cases. But it also doesn't mean that the dashboard is the world or that the world looks like the dashboard. The world as it is in itself stands to look nothing like what we call colloquially the physical world. It will be as incommensurable with physicality as a lightning storm outside is incommensurable with the dials on a dashboard. We do not have these transparent windscreens to see the world. We are airplane pilots who do not have transparent windscreens. All we have is the instrument panel, is the dashboard. Okay, normally it would be useful if you would give yourself time to let this sink in, but we don't have time for that. So I will go ahead. Some people say, well, but we can transcend the dashboard because we build instruments. We have telescopes, we have microscopes and oscilloscopes and particle accelerators. That's a misunderstanding, because whatever instruments we build, we have to perceive the output of that instrument. So everything still gets filtered through the dashboard and gets massaged into being compatible with the paradigm of the dashboard, with the dimensions or scales of the dials of the dashboard. Our measurement instruments do not allow us to transcend the dashboard at all, because we have to perceive the output of any and every measurement instrument. Okay, now let's take a step aside from philosophy and let's look at hard science. There has been a series of experiments happening in foundations of physics since the late 70s, so for over 40 years. Which this year have become very famous because the Nobel Prize was given to 3 people who have conducted these experiments. They were not the only 3 ones, but they were the most visible ones. And what these experiments, I'm putting citations here, but you can look these up if you want, but I'll give you a sort of a layperson's general overview of what these experiments consist of. And generally, it goes like this. I'm not going to be physically rigorous here because it's impossible in a half-an-hour presentation, but I'll try to give you the essence. The experiments go as follows. 2 particles are generated together, so they are what we call entangled. They can't be described independently of one another. And you could have that if you have a light source emitting photons. So you get photon A going to the left and photon B going to the right. Now imagine that after a little while, after the photons have traveled a certain distance, scientist Alice makes a measurement on photon A. And at the same time, exactly the same time, but very, very far away, because the photons travel at the speed of light, scientist Bob makes another measurement on photon B. What the experiments show is the following, and don't look at the picture now. I'll make one statement that is crucial. What Alice chooses to measure about photon A determines what Bob sees when he looks at photon B. I'll repeat this. Alice's choice of what to measure regarding photon A determines what photon B is. Because under physics, according to physics, the very beingness of a subatomic particle is determined by its properties, its measurable properties. So Alice's choice of measurement determines what photon B is. And you can do the experiment the other way around, and you can say photon A is determined by Bob's choice of measurement. That's not what you would expect under physicalist assumptions, like that the world is made of things, and that things are isomorphic with what appears on the screen of perception, because under those assumptions, photons A and B are things and they have standalone existence. In other words, an act of measurement is supposed to merely reveal what photons A and B already were prior to measurement. But as it turns out, what photons A and B are depend on the choice of measurement. So physicality is an outcome of measurement. The only way to escape from this conclusion is to entertain some woo-woo theoretical fantasy like countless parallel universes popping into existence every fraction of a second for no reason, for which we have precisely zero empirical evidence, or another one that is just as bad, superdeterminism, the idea that there are these hidden variables that nobody has ever seen or that haven't even been theoretically defined by any physicist, but there are supposed to be these hidden variables that do whatever needs to be done for the experimental result to be what it is. We have precisely zero empirical evidence for that. So these are woo fantasies comparable to the flying spaghetti monster, which is a hypothesis that cannot be refuted. For all I know, there is a flying spaghetti monster in a higher dimension, making the planets go around their orbits using its invisible noodly appendages. I cannot refute that, but we have no reason to entertain that hypothesis seriously. And I would argue that in just the same way, we have no reason to entertain two much more inflationary hypotheses like these invisible parallel universes or these undetermined invisible hidden variables. It's the same kind of thing. So if we are to be grounded in reason and evidence, the conclusion is what we call physicality is an outcome of measurement, which raises the question, what is it that we measure? What is it that is measured to begin with? There must be something that gives meaning and causal effectiveness to the act of measurement, since the physical world arises from it. Here's the way to interpret this. If the physical world is a dashboard of instruments, and each one of us has a different dashboard, and they look like they are the same because the measurements displayed on the dashboards are all measurements of the same world outside the airplane, behind the dashboard. That's why we have this intuition, which is justified, that we share the same world, because the dashboards, yours and mine and everybody else's, are showing measurements of the same world, but that world is not the dashboard. If physicality is the dashboard, now notice that what the dashboard displays on the dials is always an outcome of measurement. The airplane has sensors that measure the real world outside the airplane. The results of those measurements are displayed here on the dashboard, in these dials or in displays. That's what the dashboard shows, the results of measurement. If you don't measure, the dashboard shows nothing. And that's exactly what turns out to be the case. If we don't make a measurement, there is no physical world. We cannot speak of physical properties that exist prior to or independent of measurement. It doesn't make sense in quantum mechanics to say that. And again, this is not difficult to understand. If there is no measurement, the sensors or the dashboard can show nothing. In other words, there is no physical world, because the physical world is what is displayed by the dashboard. If you don't measure, it doesn't display anything. Does that mean that there is no world outside to be measured? Of course not. Of course, there is a world outside to be measured. It's just not physical, because the physical world is the outcome of a measurement being displayed on a dashboard. It is a representation of something relevant about the real world, but it isn't the world. It is a representation thereof. And if you don't measure, you don't represent. Okay, I already talked about this. Now, what about the correlation between the measurements of Alice and Bob? Because I told you that what Bob sees depends on what Alice chooses to measure. So they are correlated at a distance instantaneously. How is that possible? Alice and Bob are not talking to one another. How can the choice of one determines what the other sees? Where does this perfect correlation come from? Well, let me use another metaphor. Suppose there is a soccer game. It's the time of soccer right now. The World Cup is coming to an end. And the soccer game is happening in Qatar, but none of us is in Qatar. We are not at the stadium. The stadium in Qatar is the real games, the real match. That's the real thing, the thing in itself. But we are very fond of soccer, and we are not in Qatar, so we buy a television. Now, suppose I am so fanatic about soccer, I buy 2 televisions, and I put 2 gigantic televisions on my living room, and I to watch the game on 2 different channels at the same time, 2 different broadcasters. Now imagine also that the 2 broadcasters have different cameras on the stadium. One broadcaster has cameras on the south side, and the other broadcaster has cameras on the north side. So the televisions will display different images. These images are not the same, they are different, but they are perfectly correlated. If the little man on the top goes to the right, the little man on the bottom goes to the left. These images are representations. They are not the thing in itself. They're not the soccer game. We know that. But imagine that a time traveler from the 19th century comes to your house to watch the game. And he looks at these 2 boxes, and there are little men running around the 2 boxes. He thinks those are real men inside the boxes, real little men. And when the little man on the left run to the right, the little man on the other TV run to the left. Always, instantaneously, they synchronize their movements instantaneously, immediately, and perfectly. And our time traveler goes and, and moves his hand in between the 2 televisions, between the 2 boxes to make sure that there is nothing between. And he realizes the little men on one box are not communicating with the little man on the other box. So how can they be synchronized perfectly and instantaneously? Whoa, magic. Well, it's not magic. What is the error that our time traveler is making? He is taking images or representations for the world as it is in itself. He thinks that the images of little men are real little men. No, they are not. The televisions are representations of the real thing, and the real thing is far away in Qatar. It's in the stadium. The television images are representations. They are not things in themselves. That's the error our time traveler makes. And that's the only reason why he's in wonder. He thinks it's a miracle that the 2 images are perfectly synchronized, even though the television sets cannot communicate with one another, just like Alice and Bob cannot communicate with one another. But we know what's happening. We know that the images are just that. They are not the real thing. They are not what is being measured. What is being measured or observed is in Qatar. The images on the television are the result of measurement, the outcome of measurement. And they are synchronized because they are both different representations of the same underlying reality. And that is not difficult to understand. 2 television images of the same match will be synchronized because they are both representations, outcomes of measurement of the same underlying reality. And so what? Now, we think it's all very difficult because we think like 19th century people in face of 21st century laboratory evidence, experimental data. That's the problem. What the movement we have to make in our minds is to depart from this notion that the real world is physical. It is not. Physicality is a representation. It's the outcome of our measuring the real world as those measurements are represented to us on our internal dashboard of dials. So to make it a little bit more rigorous, we have internal cognitive states that I will call R. And then there is a world outside us with states, a set of states that I will call psi. Now, because we are limited beings, we can be modeled in terms of a Markov blanket. In other words, there is a set of states called the Markov blanket. Some of those states are sensory states, S, that the states of the world, psi, interact with. So our sensory states, S, in our Markov blanket, accrues information about the states, psi, of the world. And our inner cognitive states, R, are determined by S. So S is perception. There are also active states or action states, A. When we move our limbs, we are displacing air at the very least. In other words, we are exerting a causal influence into the states psi of the world through the active states of our Markov blanket. This is just a model. Our understanding of the world is here. Our perception of the world is here in the Markov blanket. That's where our sensory states are. And the real world is here, psi. But there isn't just one of us. There are many, many of us. Each one of us can be represented the same way. Each one of us has a Markov blanket with sensory states S. This is the physical world. And different people have different physical worlds. But there is only one real world, psi. And we think it's physical because the physical world, S, of each one of us accrues information or displays measurements of the same states, psi. So the S's are consistent with one another. And we think they are the world, but they are not. Two airplanes flying the same piece of sky will have two dashboards that are consistent with one another, but they are still two different dashboards, even though the measurements they are showing are consistent with one another because they are flying the same patch of sky. Psi is the same. S is mutually consistent, but S is not psi. The world is psi and it is non-physical. That's the jump we have to make. Not only is it non-physical, it is not made of things. That's why we represent psi in quantum mechanics in the form of fields. Because that's the only way we can make things work mathematically in a way that is consistent with empirical data. And now I was going to talk about the cognitive part of this whole thing, but I think I'm out of time. So this is a good point to end it.
You are. Thanks so much, Bernardo. That was really awesome. Is there a place where you do talk about the cognitive side of it that people can go find?
Oh yeah, you can go to the Essentia Foundation website. That's essentiafoundation.org. Essentia is in Latin, E-S-S-E-N-T-I-A. I'll put it on the chat. Essentiafoundation.org. And you can then do a search on courses, and you will find different courses in which I talk for literally like 6-7 hours about all these things. And there are lots of essays, videos, all kinds of things.
That's great. That's really great. Thank you so much. We really appreciate you joining us here. You are an incredibly important voice in the consciousness space, and we're so grateful for your work and for coming to share it with us today.
My pleasure, Jeff. Thanks for having me.